Well, hi, good morning. Thanks so much for joining me in my shop here on June 4th. Oh my gosh, June 4th. Hey, there's nothing on my bench. How come? What am I going to do? Nothing here. That's because it's here. That's the next radio I'm going to be working on. It's a beautiful looking radio. Just lovely. And there's a good chance it's been refinished, but whoever did it did an excellent job on it because it looks original. It's fantastic. The reason I can tell this has been refinished, well, A, I was told that. That's helpful. But B, there's no longer any identifying words or labels here on the control knobs. So they got lost in the process of refinishing it. And look at the size of that speaker hole. Now, don't be fooled. Because it's old now, there's a bit of a dirt stain. This is how big the speaker really is. It's this big. It's not this big. But isn't that dramatic? That's a very dramatic, huge hole in a relatively small floor-standing radio. A lot of these floor-standing radios are deeper and wider than this one. So this is your pocket version of it, I guess. So I believe the owners of this have plugged it in and it's done some things. This is a family type heirloom. It's been in the family for a long time, the owner of it. So let's take a look at the back and see what's up. Because there's some strange stuff going on here. Now, no doubt your eye right away has caught this. This is hanging here because I unbolted it from this hole. It was mounted here, sitting here. I don't want to put it there, but it was sitting sitting like this. One there and one here. That's pretty weird, isn't it? And this is the nameplate. The reason I had to unbolt this was to read the nameplate and get all the information that might be available there. So that's pretty odd. What's going on with that? That's very odd. First I thought, oh, it must be a case of replacing the speaker because that can lead to stuff like this, extra transformers. But if you look at these closely, this is a choke. And this one, this is a transformer. That's the center tap wire. What's going on with this one? I have no idea. So very certainly a mystery. Not a large radio chassis, fairly small radio chassis, but a very important thing to note. And you're going to be able to read it there. Maybe if I just tip this more and more and more. Battery operated. Battery operated. But it's got a power cord hanging out of it. Battery operated with a power cord. So we can guess now that these have something to do with the conversion away from relying on batteries towards being able to plug it into the powerful electric system. But it doesn't end there. This radio's also gone through a replacement of the speaker, I'm pretty sure. Let me lower my camera here. We can get a better look at it. Yep, a little bit of a problem. I can't get the one leg to go down. Just give me a second here. There we go. There. Now we can see the speaker. What's going on here? A little bit of room for myself. Well, the first thing I spot is this wire going nowhere. Well, then I see two wires going to a speaker. Means it's either the voice coil feed directly or it's feeding to the output transformer, which is at the speaker. And sure enough, there's what looks like an output transformer. Must be the output transformer. So, is this the original speaker? Is this the original board? I'm not sure, to be honest with you. Why a three-wire cable with one wire cut? So, in a lot of these older radios, the speaker didn't have a magnet built into it. It used a coil, an electromagnet, and then that coil was fed with some current, some handy current from the power supply, but then the coil doubled as part of the filter system of the AC power supply. But this is not an AC radio originally. It's a DC radio. There's no need for this kind of stuff. But it may still have, in terms of filtering AC power, there's no AC power. But it may still have had a speaker that did not have a permanent magnet on it. And so it may still have had a need for electricity to run through a coil here. But this speaker has a permanent magnet. The coil arrangement would explain why there's 3 wires coming down here, even 4 wires it would explain. Notice these wires are also cut and joined here, so something has gone on in this area. So I'm guessing what happened was at some point in the life of this radio, either the speaker failed, or at the time it was being sort of rewired with this kind of stuff. The original speaker was removed, and this one with a permanent magnet was installed, and making the 3rd wire unnecessary. Those are my guesses as to what has gone on in this radio. If you look down at the actual bottom of it, it's in very, very bad shape. It really would appear that this has been out in the weather. But I bet you it has not been out in the weather. I'll bet you what this is damage from the large battery that would have been sitting in here. There'd be two batteries generally in a radio like this. The one is a low voltage 6-volt battery, something like that. Very much like a car battery, probably a lead acid battery. It could hold a lot of power, run a long time. That battery was used to run the heaters in the tubes. And then the other battery is designed to produce a fairly high voltage. 90 volts, 45 volts, something like that. Or some combination of batteries in series to raise enough of a voltage to operate the radio. Somewhere around 100 volts. Maybe more though. Well, that big lead acid battery would run down as you played the radio. Periodically you'd have to take it and get it recharged. And typically where you would go is down to the radio shop where they would recharge your A battery. I think it's called an A battery. The higher voltage battery was called the B battery, and then perhaps it may have had even a C battery which would produce a small voltage for biasing some of the tubes. We don't know what was in this radio offhand. I don't see any remnants of the battery cord. Sometimes in these battery radios the old battery cord is still here. You can look at the terminals on it and figure stuff out. But it's been removed here. Now you can't just remove the batteries and, you know, attach a power cord somewhere in there and plug this guy in. You have to build or design a power supply. This is very curious to me in this radio that this was done. And the reason it's so curious is where is the rectifier? Now there would not have been a rectifier in the battery. With a battery operation, there's no need to have a rectifier. The rectifier is part of converting the AC power to DC. The radio needs DC to run. It can't run on AC. Nothing runs on AC. AC is good for transmitting power. Pretty useless once it gets in our houses, though. For many things, it's pretty useless. Not for everything. So was one of these tubes a rectifier tube? It doesn't look like it. One tube in a shell. Two, three, four. There's one back here too. None of them look like rectifiers. So how did they convert the AC to DC? Good question. Another thing is there would not be a filter capacitor. Well, there might still be some large capacitors in a battery radio, but in many, it just would not be the same as with a radio that's got to convert the AC power. Where's that? Where's that capacitor in here? I don't see it. Huh. So lots of mysteries here about what has happened to this radio. As I say, the owner did plug it in. He was able, he thinks, to pick up one station, CFRB 1010. Really? Well, I guess so. There are a couple things to look at here before I pull this out. Here's the antenna and the ground connections. And this is what? What is this? With a short on it. Don't exactly know what that is. Okay. Lots of interesting stuff here to figure out. I like the puzzly nature of doing this kind of stuff, puzzling it out. So I think I'm not going to plug this in as it stands. I think I'm going to get it on the bench and try to find the answer to a couple of these questions of how this was done. Whoever did this had to be pretty clever, and it would look to me like they did it with spare parts that they had in their shop. And you have to know what you're doing. Even though it looks kind of sloppy, you still have to know what you're doing to pull this off. So these old original battery radios, fell out of favor. There's a hassle, right? You have to go down and get my battery charged. Meanwhile, radios have been designed that could be plugged right into the newfangled hydropower. We called it hydropower here in Ontario or Canada because it was mostly coming from Niagara Falls at the start. At the time this radio came out, when did this radio come out? It's battery operated. Yeah, I'm going to guess the late 1930s. And this would be one of the later battery models that would have come out. That's my guess. I don't know. It's a, here's another thing. I've been looking for information on it. Okay, so here it says Eaton. Eaton Company. Now, Eaton's was a huge retail operation in Canada here. Disappeared from the scene at the time the big change occurred as retailing changed to internet retailing, and they got beat. Somehow this really icon of Canadian retail is something you would just never imagine it would go away. It went away. So that's a retailer, Eaton's. Right above it you can see Universal Radio Product. So this radio was built by a company called Universal Radio. It says right on it, manufactured for Eaton's, the Eaton Company. In downtown Toronto there's a very large mall, kind of a neat mall built in the mid-70s called Eaton's. The Eaton's Street Mall. I think it's still called that, even though Eaton's is gone. Well, so it's taking this guy out of here. Probably just a matter of a few. It feels like two screws under here. Gonna slide right out. It does have a plug here for the speaker, and that's kind of interesting too. Let's unplug it. It's interesting. Oh, what happened there? The camera was going places. In mind of its own. Yeah. So you cannot just unplug one speaker from one radio and plug it into the next. They are not in any way standard. It's got 4 terminals, 3 wires. Okay, it's probably the original plug. This is probably the original cable all the way down to down, all the way down. Okay, let me just keep going here. So you have just a beautiful day outside. What am I doing in here? Not getting anywhere. Okay, so if I'm going to sort out this, must not be a flathead screw. Sort that out. I'm going to get it up on the bench and we'll take a look at it. Okay, there we go. So let's start at the front here. It's a very, very nice dial on it. Very, very cool. Worldwide Roamer. R-O... Roamer? Yeah, R-O-A-M-E-R. Worldwide Roamer. I did look for information about this radio. Tried to find it based on the manufacturing information on the back. I couldn't find anything out about it, but having taken it out of the cabinet, look what I noticed. There's another nameplate on the side of it. This one might lead somewhere. Now, let's see what it says here. Super heterodyne radio, manufactured by Dominion Electrohome Industries Limited. I can't read the rest of it. It's too small a print. Let's try this. Super heterodyne radio manufactured by Dominion Electrohome Limited, successors to Grimes Radio Corporation. Kitchener, Ontario, Canada, licensed only for non-commercial reception of public radio telephone broadcasting by Canadian Radio Patents Limited, patented blah blah, 1930 as the last patent date. This is maybe a little earlier than I thought, but certainly in the 1930s. So if I look up under Electrohome, I'm liable to find information about this radio, except it doesn't give any kind of model number here. So the model number is where? Chassis style. Doesn't appear to be a real model number on this. Okay, well, some hunting will be required, but this is a good opportunity here. Hey, while I've got this close-up camera, let's put it to work here, and we'll take a look at a few things. So, made in Canada, secondary 6.3 volts. So this is the transformer they're using, I would guess, to power the all the heaters in these tubes, which are 6.3 volt tubes. They better be. And this guy is also bolted on the outside of the radio. It's probably just a choke coil. 115 volts, 60 hertz, written right on it. And there is this other wire coming out here. It's attaching to the case, and the case is bolted to the chassis. So, and it looks like it's coming out of the center. So, I'm not sure what to make of this guy. Is there any other wires? I don't think so. Let me look underneath here. Is there anything? Oh, there is another pair of wires. Oh, we're getting a look underneath. Somebody's been in here. Okay, let's not look too close yet. So one of these is going to be the antenna, and one is not. Now, which is which? We can't see from the front. There's no label on it. We can guess that's the antenna. That's the ground. That's a guess. What's this? It's possible this is an input point for a record player. We can only find out either with a schematic, if I can find one, or by examining the circuitry underneath. Okay, somebody's taking the time to write some tube numbers here. 6K6, 6H6. That's not making sense. This look, what kind of tube is this? I don't recognize that tube at all. That's an oddball there. Okay, 6C5, 1924 was when it was patented, so it's probably an original tube. Has it penciled in 6C5, another one, 6C5, two of them, two 6C5s. That's very unusual. Now we got two tubes here with grid caps on them. So So one is coming right back from the antenna system, basically, the antenna tuning capacitor, right to the grid. And probably the output of this tube is going into this IF. There's another one over here, so I don't know where they're going. I don't know how this is done offhand. We need to look at the schematic. In there, probably a pretty old tube in there. Pull that out now. The tuning capacitor is nothing too thrilling about it. Pretty rusty. Shouldn't really matter, but it may be hard to turn if it's not rusty. Okay, so which knob is it here? Let me change cameras again. I have the feeling, this feeling you can't tune this radio. Let's see. Am I right? So this is clearly the tuning one with the string on it. Oh, yes you can. Oh no you can't. So the pointer moved there for a moment. Not only that, the capacitor, let me turn the dial again. Of course it's going nowhere. So I saw the pointer move, but not the capacitor. Now how can that happen? So this is the drive wheel here. I'll try to turn it by hand. It's pretty rough. Oh, it takes a lot. This needs a lot of oiling in here. It's just dried up, I think, from lack of lubrication. But at least it moves. Whether the pointer is related to the... Let's see, if we close the capacitor all the way, then the dial pointer is pointing in a logical place. So the pointer is lined up with the capacitor. Good. Now let's take a look underneath. This is going to tell a big story. Which way to tip this? I guess you can tip it either way. This has got some screws sticking out. This is flatter on this side. But on this side it's got the speaker, but I'm not going to be playing it yet. Can't run this radio without the speaker plugged in. We'll tip it up this way. It's very unsteady, but there's a good opportunity here. There. That's steady. Okay, what do you show us in behind? Oh my gosh, look what's happened here. This was not done all that long ago. Holy smokes. Wowee. Well, okay, where is the rectifier? There it is. So this is a really a very, somebody put a lot of effort into this, no doubt about it. So here's the power supply, filter, or rectifier, power supply, filter capacitors. I was wondering where they were. Here they are. They're just little. The original would have been a big thing. Look, there's a battery shoved in here. This is a bad move. It's a bad move, mister. Let's get the close-up camera. Well, first let's take the... See, I got excited here. I got excited because the story's being told. Just looking it over with a longer shot. So, you know, we've got capacitors changed. Capacitor. Well, he left this one in. Well, he left this one in. This big one. You leave a big one in. And he left this one in. But he changed here. So what exactly he was up to? I don't know. This battery thing, now we're, yeah, that's egregious. An egregious thing there. I think I know why it's there. Looks like a capacitor changed here. Looks like another one maybe changed here. And they look like there's a variation in capacitor types. Could be a junk box project, but I don't know. This is pretty slick here. What he's done. Looks like it's just one screw holding this. I could just take the screw and kind of pull this away, which is a good thing. You can see one of the wires coming from the transformer here is soldered to this terminal onto the chassis. The other wire is how do you do the power cord? There's the power cord, comes in over to a switch here. This it looks like this is a 4-way switch. So typically on these battery radios there are 2 switches, so each one has its own terminals. When you look on the back of the on-off switch, there's 4 terminals. And one of them is switching the 6 volts and the other one is switching the high voltage. So I have 2 separate circuits and 2 separate switches to turn it on and off. And what this guy's done is he's taken the terminals, he's picked a couple, tied them together, and then turned it into just a single switch. That's what he's done, which is okay. There's a fair bit of tape used in here. You know, you can kind of judge the age of things a little bit with this tape. This doesn't look that old. Doesn't look like you put it on very well. This tape is hard to use in a crowded situation like this. When you apply this black tape, you are supposed to stretch it. Stretch it and then wrap it. Stretch it and wrap it. The better tape, you can stretch almost 50%. When you wrap it, when it's stretched, it tends to pull in on itself and it kind of grab onto the thing. If you just put it on loose, like Scotch tape, this is what you get in the end. It just comes off. But it's very hard to, you know, stretch it and put it on there. It's very tricky stuff. So all in all, a pretty good job, but this battery is a serious problem. Let's take a close look at what's going on there. It looks a little bit complicated to me. Why would you solder in a battery? You can see he soldered wires to the terminals and then stuck it in there. What is some of this stuff? There's a ton of copper corrosion, probably from chemicals literally leaking out and crawling down the wires to reach. So that looks like a clamp to me. That I'm looking at this part here. This looks like a clamp. Now the original battery, I think I have some right here. I have some right here. Some right here. The original battery would have looked like this. Called a carbon button battery. Has a this is probably a zinc case and carbon button in the middle, and then there's a rubber seal gasket around it, and then inside would be some kind of electrolyte liquid of some sort or something, probably just mashed up paper in there. These dry out and they stop working. Otherwise this thing will work forever. In operation in a radio like this, there's no current draw from these batteries, so they don't kind of wear out, but they dry out. So what he's done is so this thing would have been sitting, sorry for me to show it, sitting in here between those 2 white clampy things. And obviously they were designed to be replaced at some point, so maybe their life wasn't as eternal as I imagined. So you can see the amount of corrosion here that's developed on the end of it. So I'm quite tempted to just nip the wires out. You can see this lead simply going here, which goes to the clamp terminal, and the other clamp terminal has a lead coming up to the back of the battery. I'm just going to cut them and get them out of there. So, but wait a minute, the radio won't work. Wow. Yeah, let's not, yeah. You can actually just short the contacts where the battery was, and there's a good chance the radio will work okay. And in some cases, I've actually stuck in a, this is really jammed in here. Oh. I've stuck in a one of those flat like a watch battery. And actually managed to get it to hold right in the clamp. I said, well, why is there a battery in the radio anyway? I mean, most radios don't have batteries in the middle of them. Computers do. And this is not to keep the memory alive after you turn off the radio. This is to provide some bias to a couple of tubes. And nothing more. The voltage on this, these kind of batteries, is around a volt and a half. So that's lacking. If I just tie these together, then that bias voltage won't be in the radio. The result of that, hard to say offhand. On low volume settings, maybe nothing. It may sound just fine, but you may find you turn it up a little bit and it gets kind of raspy. Who knows for sure? But we'll have to do something here to make the radio work at all. And I'm not inclined to solder in another battery. Okay, any other goodies in here? So what I have to do is come up with an approach and a plan to get through basically finishing the restoration of this radio, like getting rid of this big guy. You should not have left this one in. I'm guessing what it does, but my guess is this is quieting the shield circuit on the tubes. It's a decoupler for that. Did I say shield? Screen. Now this capacitor, what has happened to it? It's gone gooky. Again, why would he choose to leave these? He had a reason for changing these ones? Some kind of operational reason that was guiding him in changing these? Or that's his standard practice? I change the coupling capacitors, the ones that got to block the B plus from grids. I change a couple others. Maybe that was his objective. I don't think we're going to know. Now, what's going on with this one? So here's a highly reliable mica capacitor, and you can see the wire's been cut and either this is a replacement, and he needs a little more solder on there, I think. Looks like it's holding in. Why? Well, we'll probably never know all the things. We'll never know all the stories that others have experienced. Look at this particular solder spot here. That's a schmozzle. And things don't look like that when they come out of the factory. So another question I have to ask myself, with the modifications that have occurred in this radio, and they are not insignificant. This is not an insignificant thing to stick into a radio like this and make it work. What else has been done in here in terms of alteration from the original circuit? Could be some, a minor thing, but if you don't know it's there, that minor thing can turn into something major. The radio's behavior won't match expectations, even though whoever did it may have done a good thing, a harmless thing. Because you can just lead to confusion on my part, and that's not hard to do. That's not challenging. Confusing Jim is easy. Okay, nothing else is popping out here, but I'm sure as I work on it, some more interesting highlights are going to pop out about what was done with this radio. Now, should we try operating it? So the owner had, can't do it without the speaker plugged in. I've taken out this battery here, so that will actually open the audio circuit, and there'll be nothing coming through. But I could just put a clip lead, and just clip lead from here to wherever that other wire's going. Looks like it's going down to the chassis. It's just a little odd, going down to the chassis. Certainly does look that way. I don't think I've interpreted this wrong. I'm pretty sure there was a battery between those holders. Well, I could temporarily put a battery there. I just do without a battery, and so what if it's distorted? That's okay. But operating it with these sick-looking capacitors, now that's an electrolytic one there. Well, it's right, and there's another one here. This must be more filter capacitors that he's got installed here. Oh boy. And this one really is connected, yeah. Because sometimes a person will disconnect or cut free a component, but leave it. Just leave it in place, or cut one leg and leave it for some reason. Doesn't look like it here. It looks like it's definitely connected. I'm just curious, is this supposed to be the replacement or augmentation for this one? It shouldn't be. This is it's probably a pretty big one. High voltage. I don't see the rating on it. Well, the yellow one's got it. I can see it. No. But those got to be substantial. These look pretty big too. These might be 50 microfarads, but they might be bigger than that. Pretty heavy duty power supplies he's put in here. And of course he has to put a choke coil in, or he wanted to put a choke coil in. I think. I'll take that back, because now I realize there's some leads down here. I don't know. What's he up to here? Typically these radios, not a battery operated one, but a plug in the wall one, has a big transformer and produces a big voltage, like 200, 300, 400 volts, or between the outside legs, 750 volts or even more. That appears to be missing, unless this is doing that. But this says 6.3 volts on it. This one says 115. It says secondary 115 30 volt amps. Don't know. Going to be interesting to sort all that out. Okay. Once again, do we operate this radio? I really like to get these things working to any degree before I really go whole hog on them, because then you can tell what's happening as you work on it. Things are getting better, things are getting worse. Uh-oh, I must have made a mistake, everything's gone dead. But you start with a dead radio, and as you work on it, it just stays dead. You just don't know what you're doing. You don't know the effect of what you're doing, and maybe you're making mistakes. I never make a mistake, but some people do make mistakes doing this work, and you make 2 or 3 mistakes. Oh my gosh. And you can almost think of this new circuit as just an additional mistake. It's not a mistake, but it's an additional curiosity, if you like. Well, the owner plugged it in, so why can't I? Okay, I'm going to dig out the speaker. Where is it? Or can I plug it in where it is? Let's see. No, I cannot. So I'm going to take the speaker out, and we'll hook it up. We'll give it a go, and that'll be it for today. Okay, here's the speaker. I get a chance to take a look at it. It's in perfect shape. I don't know why I did that. I just like to do that. So it's got a big permanent magnet on it. How permanent is it? Let me grab a screwdriver. Lots of magnetism there still. In the early days, they couldn't produce strong enough magnets to operate a speaker. I guess with material advantages or advances, they got materials that they could make more powerful magnets. So they stopped doing the coil thing down here. Stick a magnet there. Okay, that's just fine. Let me just put this. Oh, I think it's a Jensen. Did I see Jensen written on it somewhere? It's inspected by number 8. Number 8 was here inspecting it. K728B. I don't know who the manufacturer was. Let's put it over here. Okay. Plug it back in. Oh yeah, I can't plug it in. But we'll put the radio down. Anyway. So most of these radios, they can be operated on their side. It doesn't make any difference. But in some of the earliest radios, if the tube is on its side, if instead of being standing up, it's installed on its side, or for some reason you tip the radio sideways, the filament will be pulled downwards by gravity. And you heat the tube up, the filament is going to expand a little bit, it's going to droop, and it might droop into contact with another element inside the tube, and that's the end of that. So some tubes you cannot operate on their sides. Oh yeah, plugging this in here. These guys usually have two fat pins and two thin pins in this case. And it looks like the fat guys go there. Okay. It's recommended you step back a little bit. Now to power this up, I'm not just plugging it into the wall, you know, and basically accessing one of the generators at Niagara Falls. That's not what I'm doing. In between the radio and Niagara Falls are a couple of light bulbs up here. The idea is the electricity reaching the radio is going through the light bulbs. And this restricts the amount of electricity that can reach the radio. Oops. And if the radio, for some reason, wants to gobble a lot of electricity, maybe there's a short circuit in here. I mean, look at all this stuff this guy's done. If there's a short circuit, then the lights will come on very bright, and that'll tell me that there's a problem. At the same time, restricting heavy current from flowing into whatever it is that's shorted out in here. What is that? I don't know. Okay, so we're going to plug it in. Now I have to practice so we have an on-off switch. Not that. That's the on-off switch there. And the volume control probably. We have the tuning. Hey, it's moving this time. And then this is, well, we have a couple bands here. So this is probably the band switch. And this is probably the band switch. One of these two is the band switch. Let's see if we can sort that out before I... This switch appears to be a tone switch. It's switching in a capacitor. The other switch down at the bottom there, this one here, is clearly the band switch. It's located near these coils. And some interesting components down there, which I didn't really notice before, but we won't worry about those. Okay, so I'm going to switch on the radio here. I haven't switched the power on yet. This guy will tell us what the voltage is that's reaching the radio. Keep an eye on that. This is a kitchen knife that broke the other day, and I'm so cheap. I'm going to hang on to the blade because I think somehow it'll be useful. Yeah. Okay. And here comes the cat. So over here I have this ridiculous control panel. This turns the power on to the control panel. This switch directs the power either through the lights to get to the radio, or yeah, I can actually hook up right up to Niagara Falls if I throw this upwards. So downwards through the lights, upwards Niagara Falls. It's actually not Niagara Falls. I get my power from a fat nuclear plant, a couple of nuclear power plants. A lot of the energy here in Ontario is generated in 3 nuclear power plants, large stations. Okay, we hit the switch, we watch the lights. What? What are you saying? Was that so, eh? Looks like I might have to stop for a minute and deal with this thing. Shadow, what was it you want? You want to go outside? That was it. Did you see it? Did you see the little tip of her head? You know how when somebody says, where's the thing? And you throw your head, you go over that way. Over that way. Let cats do that. Of course, you have to speak English to know what the question is. But okay, I'm going to stop for a moment, go and get my cat settled down. Then we're going to turn this guy on when I come back in just a second. Okay, cat's outside. Now, I was about to say, so if everything's working normally in this radio, when I hit the power, these lights will come on fairly bright. They'll come up fairly bright. Then they'll go down a bit. What's happening there is the heaters are heating up in the tubes. But first, the heaters are cold, so the resistance is low, and the electricity wants to rush in fairly quick. and it's going to be caught by these bulbs basically. So that's what will make them glow fairly bright, but pretty quick they'll come down. They won't go out, and then they'll start coming up again. Now what's happening on the second way up is now the tubes are heated up, the high voltage is being distributed through the radio, and I just realized, oh my gosh, there's a wire hanging out there. That this is going to work a little differently. Normally it has a rectifier that's a tube with a heater. It takes time to heat up and get going, so the B plus high voltage appears later in the game, a few seconds later. That's why you turn the radio on, you wait, and then the sound starts coming up. That, to a large degree, that's the rectifier starting to operate and produce the high voltage. This one doesn't have a tube rectifier, it has a solid state rectifier in it. So when I turn it on, the high voltage will be there right away, instantly, waiting for the tubes to warm up. Not quite the best way, but it's a way, and does it really matter? Doesn't matter anymore. So what do we expect then? So in this case, the lights should come on, and then should go down, but not too far down, and we should be hearing the radio pretty quick on the way down. That's my guess. That's my belief. And we'll put the volume about not quite halfway up. There's a light. There's no light. There's no light to light this panel up. Really? Oh, that's kind of a drag. A nice light lighting this up, but this is a metal panel. It's not glass, and this markings there on the front of it, it would have to be lit from the front. No light. There we go. 3, 2, 1. There it was. It was pretty pitiful, wasn't it? It came on and went down right away. Okay, let tubes warm up. Man the volume control. There we go. Okay, got a terrific, not terrific, but have a hum there. Doing the kind of work the fella did would be very challenging to get a good result out of that without getting, a hum or something introduced to it, but not necessarily because of what he did. Other things could be causing this. You know what it is? I know what it is. I took that battery out and I didn't put the clip leads in. So we're never going to hear the radio right now. I booped up, cut the power, but notice, no smoke, no fire, no flames. Now grab a clip lead here, and we're going to short out where that battery was. Okay, we're going to tip it up this way. There we go. There's no power fed to this radio right now while I'm doing this. Okay, where's the, here it is here. Go on to this terminal. Pieces of the radio are falling out. And the other terminal, well, it's the chassis. The other terminal is the chassis. Okay, so that being the case, put this like this here. So the clip lead is under the chassis. And I'll be able to, oh, did I just poke a hole in the speaker? I did. Oh, son of a gun. I just poked a hole in the speaker. Not the end of the world by any means, but And I put it here with the cone up. I thought to myself, I didn't say anything. Ooh, that's a little risky. God, I jammed this corner right into the cone here. But this can be fixed. That's not going to be it's not a disaster. Not a disaster. So we'll just clip this onto the chassis in some really nice spot. Some really nice spot. Well, a really nice spot. Clip on. There is no really nice spot. Oh, the bums. Okay, well, pick not so nice a spot, but I've spotted something else in the meantime. Oh, this is a good spot right here. Right there. So you know what I've spotted? There's a wire off here. Now, this wire is soldered to this can. This shield around the tube here is very important. This really does need to be soldered to the chassis. It could be the buzz we heard was from that. So there we go. We're gonna solder this back down to the chassis. May or may not have had an influence on the radio. This is the first tube. It is hooked up basically to the antenna and the capacitor here. So it's very sensitive in the sense that whatever happens to this tube gets amplified through the radio. So a little bit of hum here, big hum coming out of the speaker. Let's see. Now, soldering to the chassis is not the easiest thing, because the chassis sucks the heat back. Which is probably why this popped off. My little soldering iron's really not the best for this. We need a big, like a blowtorch practically to do this. But I just want to tack it on there. I'll hook it up some other way. This isn't going to work here, I don't think. I just want to get just a little bit will do it. There, got it. Now the other shield, I don't see a wire attached to it, but there's a chance the other shield is slid down onto some fingers that are sticking up from the chassis, and that's where the contact is. There. Okay, so we have the jumper in now, so the audio should make it. What are we going to hear? Here we go again. Didn't I say something about standing back? Stand back. Okay, here it comes. Sounds like the same hum. Could be two hums in there. Well, two hums, better than one. Try and tune this guy, but we can't. But I can. There's no antenna on it. So far-fetched. Oh! Now, hear that sound? Okay, that's a received bit of interference, that sound. I'm injecting, I've got a lot of noise in me. Just ask my wife. So the radio is doing its job to some degree. Now, did you notice when I first was turning the capacitor, the tuning capacitor back here, let's see a little more this way actually. The radio was fairly quiet and then it kind of popped into life. That suggests there's a short in these plates. Ooh, this is not. That's not very good. Don't know what's going on there. Again, so we cannot tune it with the string yet. Yeah, so that scratchy sound is from all this stuff. I see the plates are mostly unmeshed, so the chance of a contact between the sets of plates is way down. In fact, so there's no contact now. So just looking at them, I don't see any of them are egregiously bent. So we'll have to figure that one out. Could be rust has built up on them, and the rust is actually making contact. I don't know. Hey, look at that! I can actually tune it. So it sounds like a radio. Now, on the broadcast band, with the capacitor open, we're tuning up at the high end, and there's virtually no stations to hear. But what we want to do is the finger test. I am going to touch the antenna terminals, what I think is the antenna, to see what happens. Nothing. Nothing. Not a good sign. You would expect a response from that. I would. Maybe you don't, but I would. So let's be even more shocking here. This is a lead to an outdoor antenna. Wow, nothing happening there. That's quite interesting because it's picking up something. So what if I touch it here? Well, that's what we would expect from touching it here. Yeah, now, interesting. Okay, so what if we put an antenna in that stupid location? I shouldn't say stupid. Down. Stick an antenna connection here. Right here. Now, even though this is an outdoor antenna, it's crummy on the broadcast band. Everything is these days. There's so much noise and interference. We'll go on here. Tune the radio. It's not bad. Getting quiet. Down here there are stations. If it does sound like it's and I don't know for sure that this is the AM band, the broadcast band. Whew, sorry about that. That was pretty loud in here. So now I figured out what was this one was a tone. I think yeah, that's a tone. Leave it on high. We'll change bands, but I probably can't do it with my fingers. Let's stick the knob on here again. Now these shafts, they have a flat surface on them, and the idea is to have the screw that's in here made up of a flat surface. And there. There we go. 3. 3 settings. One of them very quiet. Oh, I apologize for that. That blew me out. A lot of volume out of this radio. Okay, we'll try this out again. Well, so it's tuning. The radio is largely working, it's just not working well. Those heterodyne sounds, probably maybe from that big capacitor the guy left in. I'm not sure. Okay, I think we've hit the end of and the last setting, probably phono. And that's probably what these are. And he has them shorted for unknown reasons. Maybe if they're open, there's a buzz when you flip there, if you don't have your record player hooked up. Could you feed Bluetooth in there? You probably could. But, okay, we'll check it and switch it off. Good, the off switch works. That's good to know. There we are. So what this has done today is it's enabled me to see enough of this radio that I can make up a plan in my mind about how to approach fixing it in a logical, stepwise way where we're generally just making it better with every step we take. Hopefully. And it's not I mean, it's straightforward stuff. Look, this wire I soldered just popped off back here. It never did hold. The other thing it's done, because we can hear the radio picking stuff up, it proves that all these tubes are working. Maybe they're not working great, but they're all working. The volume's really high, which is a really good sign. And it also tells me that the transformers and the coils inside here are good, and other coils that are underneath are all in good shape. That's pretty good. That's pretty good. And I have a chance now to find the schematic if I can just use this name tag and somehow do that. The schematic is extremely important. Not absolutely necessary, but especially with a radio like this that's been altered, maybe the schematic is just going to add to the confusion. But well, thanks a lot for watching, It's a beautiful day outside again. I'm going out to shovel dirt most of today, so I'll be very sore by the end of today. Thanks a lot for watching. We'll see you.